Your next speaker is Kelsey Hightower. He works at CoreOS. He likes Twitter and rockets. So let's introduce our next speaker. All right, we're going to talk about rockets. How many people like rockets? I like rockets. This is me. I have a rocket pack on. I'm a developer advocate at CoreOS. Also a proud gopher working on things like Kubernetes, Golang standard library sometimes. But today we're going to talk about Rocket. And the thing I want to focus on today mainly is how simple the actual image format is. Right? So when the news came out today, a lot of people looked at this as Rocket is this big competitor to Docker. But what was missed in the context was there's this standard image format that you can use between various tools, and we hope there will be more than one. So today there's Rocket, and what we're going to do is just demo building an image container from scratch. And then we're going to talk about what it takes to host your own private registry, right? So you think about containers, one thing is, how do you share these with other people? And then finally, we're going to talk about launching Docker images with Rocket, right? How does that work? What does that flow look like? And then I have no more slides, right? So we're going to try to do this all live demo. Rocket just came out this morning, so I don't remember all of the command line arguments. So I am totally going to cheat and follow my own tutorial. Just pretend it looks like I know what I'm doing. We'll probably edit it out so it looks much smoother. So here's the Rocket tutorial. Like no stars. Let me fix that really quick. Oh, 3. Concurrency. All right. So here's Rocket. What I'm going to do is I'm going to start with a very simple static binary, a little Go Hello World app. All you guys should be using Go. If not, Brad will probably find you and convert you. All right, so this little Go app is very simple. It's just a little Hello World app. And what I want to do is statically link this so we don't need any dependencies, because I really just want to focus on running this particular container. So what I'll do is I'll compile it really quick in a way that won't produce any dependencies. So we'll grab this, takes a few seconds, and once we have that, we have this nice binary. And then we need to create a metadata file. So Brandon talked about the manifest. And what the manifest looks like is a little bit of boilerplate about the version of the app manifest that you have, and a name of the actual container image that you want to serve up. And then we do support things like OS and Arch, because that compatibility may be a thing in the future. And then you also give it kind of like your entry point. Where should we start executing when this container runs? And then we can give it a list of ports, basically a hash of a collection of ports and their names. And then a couple of annotations. There's other annotations, but here I just kept Arthur, like who built it. There's other things that you can add in there, and I can see this being extended in the future, maybe for search implementations or more robust registries. So once you have your manifest file, you need a root file system. So what I'm going to do is create a root file system for our container. And then I'll just put it in bin. It really doesn't matter. I could have executed it at root. And what I'm going to do is copy that static binary up. So we'll throw the static binary up. So what we have now is our binary, a manifest, and a pretty empty root file system. The next thing we're going to do is copy over our binary into bin. So that's pretty much everything that we need to build our first container. Now, one thing that the implementation shipped with is a little tool called AC tool. And you can use this to validate your manifest, your root file systems, and ultimately your application container image. So what we'll do right now is validate the actual manifest file. And this should catch errors like invalid JSON or using metadata that the system won't recognize. So if everything looks good, you'll see something like that. And then once we've built our root file system, you should be able to validate that too. But what we're going to do is go ahead and build our image. So what I'm doing here is basically saying I'm going to use AC tool to build. I'm giving it the path to my manifest.json, and then the root file system that I wanted to use, and the name of the output file. So ideally, you could see yourself doing this from like your CI systems or some other automation tools. So that's it. We basically have what is effectively a tarball. I'm not sure if we're compressing it right now by default, but usually it's compressed. And now you have this image, and my image is pretty small because I don't have any dependencies, just basically my binary in there. and a little bit of metadata that was appended to it once it was created by the AC tool. So once we have that, we can actually validate that to make sure that this image will actually execute. And the validation is really important. So for people that are making their own implementations, you can use these validation tools to make sure that you're actually producing the right thing. Keep us all on the same page. So we validate that, and we know we now have a proper app container image. And now the simple part is running the image. So I'll just do rocket run, and it's up and running. Now, this is systemd complaining that there is no time zone file in place, so it's not going to set my time zone. And to validate that this hello world works, I'll just pop into another terminal and give curl a go. And please do not embarrass me, curl. Yes, hello world works. And we have an executing container. You guys should clap, because this is like history right now. All right, so that's gone. All right, now the next thing you want to do is you built these wonderful containers. You want to host them somewhere. So on my Mac, I just did brew install Nginx, and I have Nginx running already. You can see it here. Let's make sure it's still running. It is. And then what I'm going to do now is I'm just going to copy down that application, that app container image. I'll just bring it down over here. And now we're going to build a private registry, right? This is very complex. People actually make a whole business off of private registries. Quay is one of them, quay.io. All right, so what I'm going to do now is I'm going to push my container into my private registry. You ready? That's it. All right. So now we have a private registry up and running. You can host unlimited containers too, at least as much disk space you have. So ideally, now that I have my container hosted on my private registry, I'm going to keep saying that because it sounds like really awesome. I'm going to run it. There it is. It's running from our private registry. One thing that I like about this is it's really simple, right? If you already have HTTP infrastructure, a lot of people that are running their own Yum repos or app repos, you already have HTTP set up. You can just set up a new namespace for your containers and start serving them up there. So Brandon earlier talked about the meta tags. If you basically want to have one index site and hosting things on maybe GCE or some other repository like S3. But for most people that are internal to their network, you can just throw things there and just use convention to find things. So this makes it really simple. Let's validate that that actually works, and it does. All right, so the first thing when this came out, someone hit me on private on IRC and said, can I convert all of my Docker containers? And I was like, wow, I don't know. Let's try one, right? So on the plane, and this better work. I only practice it twice. So if it doesn't work, just giggle softly so I don't hear you. But we're going to try to take an etcd container from the Docker hub. And we're going to just do a pull here. I pre-cached it, so in case Wi-Fi wasn't correct, but at least we have an updated version. And what I want to do is essentially flatten this Docker container. I don't want all the layers. I just want the root file system. Now, in order to do that, I need to run it one time so I can actually export the actual container. So we can't do anything with the actual image, but we can do something with the exploded container. So I'm just going to run this once and give it a name, so that way I can export it easily. So it's running. I don't really care. I just need Docker to do my dirty work of building the container. Now I'm going to jack Docker's container, first by creating a root file system. So now I have the root file system kind of staged. It's empty now. What we're going to do is have Docker export the actual container that's exploded on disk. And I'm using tar and some other bash foo to put this container in our root file system. Right, so we do that, and there it is. So now we really need to install tree on CoreOS by default. But so we have this root file system, so everything's there. So now I basically have that same Docker container exploded, ready to go. And then what I'll do now is, actually I don't want that etcd data directory. Actually won't cause problems, but let's get rid of it. So once that's in place, ideally, we should be able to create a manifest file for it. And let's use the actual manifest in place. So the manifest looks just like the other one, except for I give it its entry point, and here it's etcd binary is at the root of the container, and I give it a name, basically the only argument that etcd requires. And then here I specify the ports. And what we've been doing with the networking so far is effectively equal to running docker net equals host. Right now we're not attaching to a bridge or anything. We're using the host network namespace. We do have a PR in place that will add the fundamentals of Docker networking, but you can bet you that'll be pretty flexible shortly. And a little bit of annotations here. So pretty much the same thing we saw with the Hello app. So once we have that manifest in place, we'll build the etcd container. All right, so that's built. Let's see what the size of that guy is. All right, so it's about 20 megs. There's a lot more data in there. We need some SSL certificates to make etcd work. And ideally, if everything is on my side, we should be able to run this command, and we should be able to run a Docker image. There we go. It looks like it's working. Let's ask etcd to validate. etcd ctl set foo bar, and yes, our etcd container is now running under Rocket, downloaded from the Docker Hub. Okay, that's the end of my badass demo. Thank you. I would take questions, but we're about to have this panel, so we can kind of just group all those questions there. But if any,
I would say take some questions about this, what you just did.
Okay.
And we're probably going to take a little break so people can refresh their drinks and so on, and
okay.
Then we'll do the Q&A. So if you have questions, again, specifically about this demos and stuff, let's do that now.
All right, Brad?
Why does AC tool validate output things to standard out on success, which is not really Unixy when AC tool builds this?
It's for the, so the question was, why does AC tool output stuff to standard out on its success? And it's because we can do that, Brad. It's our project. No. We will accept pull requests to change that behavior. Maybe we should do it on the verbose. But this thing launched this morning. Like, give us a pass, right? You know, it's totally an open source project. We have already gotten a few pull requests so far. So if you see things that should change, let us know. But it makes a good demo to show things.
Does Rocket only runs on CoreOS, or it's an open source project and run on any Linux?
So the question is, does Rocket run only on CoreOS? And the nice thing is that Rocket, the actual stage 1, is statically compiled. So it's basically some systemd stuff all bundled in one bundle. And you should be able to run it on Ubuntu, CentOS, and ideally it should be cross-platform. So it's self-contained, and ideally we'll probably see other stage 1s and stage 0s that implement part of the specification. So yes, you can run Rocket on other platforms.
Is this in the alpha image now?
The current image? Yeah, the current image should work. I don't know if we've merged Brandon's pull request to statically compile systemd and all the bits that we need to do the stage 1. But I believe it's working now, so you can try it. If not, it's a bug.
You mentioned that currently you just do host networking, and there's a plan to have bridge networking in the future. Is that going to be optional?
Yes, so the networking model we believe should be as flexible as NSpawn currently used by Rockets will support. So you can turn networking completely off. You can just do net equals host like we're doing here, or you can use our default implementation of a bridge. We don't even know what the default will be. I mean, it's that early where we're trying to get feedback on what people want. But ideally, we'll support the common use cases and make that pluggable.
Can you go back to the slide where you had exec, etcd, node, something, something? It was a JSON list, but you had one string element that was space separated?
Where you at? Here?
Yeah, there. Like, what is that single string? Is that supposed to be like parsed like a shell?
This is me going quick. So ideally, it's you could give an array of arguments, so the binary and then all of its argument as a string list that we pass to OS exec. Right, so ideally, I just put it all in one part of the string. I could have separated that by commas. So it could have been etcd, flag, argument, and so on. Brad, you're trolling us, man. Any more questions?
I think save your awesome questions here for this next phase. Thank you, Kelsey. Woo!